All right, so we're going to talk about naming compounds now, and we're going to name inorganic compounds. All we're going to name is inorganic compounds, and it's a lot. Okay, so I'm going to go kind of fast because this is a nice thing about doing things on YouTube is I can give you the rules, and we don't have to stop and re-go over them and go over them again and again and again. We just I'll give them to you once. If you want to hear them again, then you can watch the video again. And you don't even have to take that good of notes, right? You just have to take enough notes to get through. And really, you're going to learn these by practicing. All right, so let's get started. So first of all, when you're naming ionic compounds, you name the cation first. And the cation is going to be the element in front, right? So the cation always goes in front. If you're going to name, you name the cation and you name it simply. The cation is named the name of the element, right? So let's use this one as an example. So this is sodium as an element, but when it's a cation, it's also called sodium, right? The anion is named for the element, but we drop off the end. Watch this, chlorine, and we put IDE in its place, right? So you knew that this was sodium chloride because you've seen it before, but this is the reason why. Sodium doesn't change its name for the element, and chlorine gets changed to chloride, okay? So a polyatomic ion, when it's the cation, is just given the name of the ion, well, either the cation or the anion. So sodium chloride, potassium bromide, calcium iodide. Notice we don't even have to say 2. We don't have to say that, right? Because iodine is in group 17, which takes a charge of -1. Calcium takes a charge of +2. And so there must be 2 of these, right? So we don't even use that. We say simply calcium iodide, cesium fluoride, lithium chloride, sodium oxide, right? And we don't even have to say that there's 2 there. We know that there's 2 because this takes on a +1, so there must be 2 of them. And this takes on a -2. All right, cadmium sulfide and so on. So that's the name of some ionic compounds containing monatomic ions. Now, polyatomic ions are actually simpler, right? So we know that this is acetate because we memorized it. And here is potassium. We know that this is ammonium. And so this is going to be chloride. Here's sodium, hydrogen carbonate, or bicarbonate. Those are 2 names for the same thing. Here is calcium and sulfate and so on. So polyatomic ions, if you have these memorized, they're much easier, actually. If you don't have them memorized, it's impossible. You can't do it. So, but if you do have them memorized, you're like, oh, that's no big deal. Now, some ionic compounds are made with metals that have variable charge, right? You saw in a previous conversation that iron could be +2, or it could be +3, right? So if it's +3, then we name it iron 3 chloride. If it's +2, that would look like that. We would say, right, this would be +2, right, because these are all +1s, or rather -1s. So there must be 2 of them, right? So this is iron 2 chloride, right? And mercury 1 oxide. That's if it's got a +1 charge on it. Mercury 2 oxide. That's a tricky one, right? See, sometimes people look at these numerals and they think you know that this is iron 2 and here's iron 3, right? So they're thinking, oh, that's where the 3 comes from, but it's not, because look at that. That's mercury 2 oxide, right? Because this oxygen's got a 2- on it, and this mercury must have a 2+ on it, right? And so it's called mercury 2 oxide. So watch out for that. Now, naming covalent compounds is much simpler. Much, much simpler. For these, we simply say we name like the cations and the anions, but we actually say how many are there. I know that wasn't very clear. Let me say it again. The name of the more metallic element, the one further to the left or to the bottom, is named first. Carbon. Let's do CCl4, okay? Chlorine, right? So We named this one is more to the left, so we call it carbon. We put that to the left. All right, and it's named first. And it's also going to be on the left of the molecular formula. So it's carbon, and then we change that to chloride, just like we do the ionic ones, right? But we're going to say how many are there now, and since there's 4 chlorines, we're going to say carbon tetrachloride. Okay. So, and we do that for all of them. So if it's 1, we'll say mono. We don't always use the mono. If it's 2, we say di. 3 is tri. 4 is tetra. 5 is penta, hexa, hepta, octa, nona, and deca. All right, so those are the numbers that are going to help us with that. When only one atom of the first element is present, when it's the first element, like CCl4, we didn't say monocarbon tetrachloride, right? We just said carbon tetrachloride. So we oftentimes don't use the mono if it's the first element. And when 2 vowels are adjacent, we sometimes get rid of one of them. For example, let's use CO. That's an ugly CO. Right? This would be carbon, oxygen, oxide, right? Carbon, and we would say monoxide, but we get rid of that letter there. So we would say carbon monoxide. Can you see that? Carbon monoxide. All right. So names of some binary molecular compounds: sulfur dioxide, boron trichloride. These, you can see these examples. You don't need me to read those to you. All right. Now, naming acids is another animal altogether. When we name acids, here's how you know you have an acid. You have an acid if you have a leading hydrogen, right? HX, that's going to be an acid. Got some people coming in the kitchen here in a second. I'm going to try to give them the signal not to make too much noise here. All right. So naming binary acids, we go like this. Sorry, I got distracted there. I got people come in. So some compounds containing hydrogens are members of an important class of substances known as acids, right? We've got our leading acid here. Got distracted there, beg your pardon. That would be an acid because it has a hydrogen on the front. A mixture of an acid with water is what makes a mixture of an acid with water is given a special name to denote this property. All right, so we'll basically say blank acid, right? So here's how the names go. I know that was not clear. Here's how the names go. So first of all, the word hydrogen is changed in the prefix to go as hydro. So we're no longer saying hydrogen. Like if we were naming this as a covalent compound, we would say hydrogen fluoride, right? And when it's a gas, yes, it is hydrogen fluoride. But when it's mixed with water, we denote that by saying aqueous. Then we do this. We say hydro, okay? And then we get rid of that and we put ic acid. You see that? So this would be hydrogen fluoride if it were not an acid, if it were simply as a gas, right? And if we're naming it, if we put it in water, we name it for its as an acid. We would say now hydro, and then we would get rid of the "ide" and put ic acid. You see ic acid here? And look at the same thing goes for this one. Hydrogen chloride, if it's not in water, if it's not acting as an acid, but if it's in water, it's an acid, right? And we know it's an acid because it says aqueous here. Then we're going to say hydrochloric acid, right? Hydrobromic acid, right? Hydroiodic acid, right? Hydrosulfuric acid, right? That's how that goes. All right. Now, naming oxoacids is, I'm going to say, I think it's easier. Of course, I've been looking at this for a long time. So naming oxoacids, those are binary acids. Let me go back for a second. These were binary acids because they don't have oxoanions in them. It's just 2 elements, right? HF, HCl, HBr, HI, H2S. Those are called binary because there's only 2 atoms in them. Now, oxoacids have oxyanions in them, right? Hydrogen, oxygen, and other things, okay? So to name oxoacids, I say oxoacids. Look, there's the author of this text calls them oxyacids. Okay, same thing. They omit the word hydrogen. They start with the root name of the anion, and then they replace the ate with the ic. This is going to be easy. You can see why this is absolutely critical that you know these polyatomic ions. Critical. So if we have acetate, then we name acetic acid. So acetate, C2H3O2, and if this is acetate, oh, that's a minus, right? And if we put a hydrogen and H plus on the front there, then we call it, watch this, acetic acid. Okay? So we get rid of the H and we put ic acid. Let me go back now. If you have an ite, you call it us acid, right? So, excuse me, so nitrite, you see nitrite? When you put NO2 minus is nitrite, right? But when you put the hydrogen on the front, then it becomes nitrous acid. Perchlorate, that's perchlorate, ClO4 minus. But when you put a hydrogen on the front, it becomes perchloric acid. Carbonate is that, because we memorized it, like that's carbonate, right? Well, there's two minuses here. So if I'm going to make it an acid, I got to put two H pluses in the front, H2CO3, and it becomes carbon. So instead of 8, it becomes ic acid. All right, and that is it. It's going to require some practice. So those are the rules, but you're going to get these in your homework, and I encourage you just to pull the rules out in front of you as you're doing this nomenclature and do it over and over and over again until you think it's easy. It will become easy to you at some point. It did for me, and it just took practice. All right, good luck.